Hey scholars, I hope you're doing great. For this lesson we are going to shift gears a little bit and we're going to meet a new friend named I. I is an imaginary number and we're going to talk about how to simplify imaginary numbers as well as how to simplify powers of I. So take good notes, make sure your slides are pulled up so you can follow along. Let's get going.
So let's start off by asking this question. What are the zeros of this function? Well, this is kind of weird. This quadratic function does not cross the x-axis anywhere. So it doesn't seem like it has zeros. However, this function actually has imaginary zeros. We're going to talk about that in future lessons a little more, but for today's lesson, we're going to actually just get a cursory understanding of what imaginary numbers are. So before we talk about imaginary numbers, we have to have an understanding of what the imaginary unit is. We call the imaginary unit I. This is going to be our new friend I. Make sure you tell I hello. Now we define the imaginary unit I as the square root of -1. You may have wondered, why can't we take the square root of -1? If you put that in your calculator, you should probably get a message that says error. Well, we can't actually take the square root of -1. It's an imaginary number, and we call that I, as you can see right here. Now, imaginary numbers can be written in the form bi, or b times I, where b is a real number and I is the imaginary unit. So an example of that would be like 3i, or 9i, or -5i. Those are examples of what we would call imaginary numbers. This is I squared. I squared, if you take the square root of -1 and you square it, remember that square roots and the exponent of 2, well, they are inverse operations. So if you square a square root, then that's going to set that number under the radical free from its cage. So you see, when you have the square root of -1 and you square it, that sets -1 free from its cage. So I squared is the square root of -1 squared, which is just -1. Keep that in mind. That's going to be helpful for us down the line. So next, we're going to work some problems over how to simplify imaginary numbers. Here are some examples that you can look at on Google Classroom. But we're going to practice working these out together. So let's try number 1. We want to simplify 3 times the square root of -16. Okay, so we have 3, and then we're going to try to simplify this radical here. Well, what we can do is we can separate this as 3 times the square root of 16 times the square root of -1. Because the square root of 16 times the square root of -1, since they're both under a square root, you can combine them and get the square root of -16. But what we're doing here is actually the opposite of it. We are breaking the square root of -16 apart, and the square root of 16 times the square root of -1. Okay, so 3 times the square root of 16 is saying 3 times 4, and then we're multiplying that times the square root of -1. Well, we know the square root of -1, we can rewrite it as just I. So 3 times 4 is 12, I. So your final answer is 12I. Okay, so now we have number 2. It says to solve the equation x squared equals -81. Well, let's say those x squared equals +81. We would just square root that junk on both sides and we get x equals positive or -9. Well, since we have x squared equals -81, we're still going to square root that junk. So we'll get x equals positive or negative, but then we see that it has negative under the radical. So we know that I is going to be in our answer. Whenever you see a negative under the radical, you'll know I is in your answer. So instead of positive or -9, you're going to get positive or negative 9I. And there you go. So now let's discuss the powers of I. Let's look at this chart to help us out a little bit. Now, this says I to the 0 power equals 1. Well, that's true because anything to the 0 power equals 1. We can talk about that more in class if you'd like. Now, I to the first power is just I, or the square root of -1. Okay? And we talked about this earlier. I squared equals -1. I told you it would come back later in the lesson. Now, I cubed equals -I. Let's think about why that is. Well, we can take I cubed and we can break it up as I squared times I, because that's I squared times I to the first, really. I can write that right here, that exponent of 1. And whenever you multiply exponential terms, you end up adding the exponents. And that's true only when they have the exact same base. So their base is I, so we can just add the exponents. So I squared times I to the first power is just I cubed. Well, check this out. We have I cubed, and I can replace I squared with -1. So that's like saying -1 times I. So -1 times I is -I. So I cubed is -I. Now the reason I to the 4th power equals 1 is because we can say I to the 4th power equals I squared times I squared. Because remember, we can add the exponents. We can break it down like this. So I to the 4th would equal -1 times -1. So we get I to the 4th equals +1. If we want to try to find I to the 5th, we can say I to the 5th equals I to the 4th times I, and we know I to the 4th is 1. Then we have 1 times I. Well, I to the 5th equals 1 times I, which is just I. So that's where all these come from. And we could keep doing that with I to the 6th and I to the 7th. Okay, so these are the powers of I. Now I to the 6th, that's like saying I to the 4th times I squared, because 4 plus 2 is 6. So I to the 6th equals 1 times -1. So I to the 6th is also -1. So lastly, let's do I to the 7th. Well, I to the 7th is I to the 4th times I cubed. Well, we know I to the 4th is 1 times I cubed. Well, we should know that's -I. So I to the 7th equals 1 times -I. So I to the 7th is -I. So if you can understand these first 4 powers of I, really I to the 0, I to the 1st, I squared, I cubed, and I to the 4th, you'll be able to simplify any power of I, which is what we'll practice doing on this next slide. Alright, so now let's finish this up by simplifying powers of I. So remember, the powers of I, that cycle repeats every 4 powers of I. Okay? So what we're going to do is we're going to look to simplify I to the 14th power by taking the number 14, that exponent 14, and dividing it by the number of powers in every cycle. Because like I said, it restarts every 4 powers of I. So how many times does 4 go into 14? Well, it goes into 14 3 times. Now 4 times 3 is 12, so 14 minus 12 is 2. Now I'm not worried about how many times 4 goes into 14. 3 just tells me how many times the cycle repeats every time, and I'm not worried about that. You'll see what's about to happen here. I'm worried about the remainder. The remainder is 2, so I to the 14 power equals I squared, which, like I said earlier, is just equal to -1. So I to the 14th power equals -1. Now let's try number 2. This says I to the 21st power. Well, I'm going to take 21 and divide it by 4. And so 4 goes into 21 5 times. 4 times 5 is 20, so 21 minus 20 you have a remainder of 1. So again, we're not worried about how many times 4 goes into 21. We can throw that 5 out. We're worried about the remainder. So we have I to the 21st equals I to the first power, which is just I. Anything to the first power, it's just itself. So I to the 21st power equals I. There you go. That's your final answer. Now, lastly, we have number 3, I to the 31st power. So we're going to take 31, divide it by 4. 4 goes into 31 7 times. So we're going to say 4 times 7 is 28. 31 minus 28, you have a remainder of 3. Again, not worrying about 7. We're going to now say I to the 31st power equals I to the third power, which, like we said earlier, is equal to negative I. Make sure you have this memorized. I to the third equals negative I. So, therefore, I to the 31st power equals negative I. There's your final answer. And that's how we simplify the powers of I.
So I hope you learned a little bit from that video. If you have any questions or things you're struggling with, I suggest you rewatch parts of the video and try to understand it a little better. But also just come to class with questions and ready to work. I'll see you then. Good work today. Thank you, Collegiate Scholars.